Hi, my name is Thomas and I'm working for Metros.
Excellent.
In our today's tutorial video, I would like to show you how you can test a breather valve with Metros equipment. For this purpose, Kito Armaturen, a German manufacturer of breather valve and flame arresters, was so kind to provide us one of their breather valves. If you would like to learn more about their products, please visit their website under www.kito.de. Now we are going to disassemble the valve to show you the inside and how it works. The hood in the top is only a protection against weather conditions like rain. We can have a closer look into the valve itself. On the top we find now a retainer, means these bars are only necessary to keep the valve seat inside the valve body, that it will not get out. Now we can see clearly the function of the vacuum unit. Means in the center I have a spring-loaded spindle. Onto the spindle underneath is fixed the seat plate, and the spring will hold the seat plate against the upper seat area. So under normal condition it will remain closed. But as soon we create a vacuum inside the tank, this will open and fresh air can get back into the tank. But how does it work if we get overpressure into this valve? Or into this tank? In this case, the entire part will move upward, and the weight will hold the seat downward. But as soon we have a certain overpressure in the tank, this part will move upward. You remember the retainer, which I have removed before, will just protect that the entire seat will not go out. But how can we test now such a breather valve? Because we need to go into the positive pressure, but also in the minus pressure, means vacuum, to be sure that the function is there, and also to test at which pressure it will open. On the type plate we can see this valve will open against overpressure already at 20 millibar, and it will open with vacuum test at already minus 10 millibar. So very, very low pressures. And for this reason, Metros has developed a special unit vacuum tester SVV002. The Metros vacuum tester, it's a very compact and mobile unit, and you can adapt it to any other clamping table from Metros test benches. It's also not strictly required to have even a clamping table from Metros. You can also use C-clamps just to clamp the vacuum sealing plates. Because, as I mentioned already before, the pressures we are going to test are very low, so there's not a big force required to hold the valve in place. For this video today, we are going to use the clamping table from our SVM20-200. But we are not going to use the control panel. No, we only use the vacuum sealing plate with the vacuum tester on the clamping table. So first of all, we are going to prepare the clamping table for the vacuum test. I remove the safety valve, which was tested before. Then I'm going to remove the original O-ring sealing plate from the SVM20-200. And now I'm going to use the vacuum sealing plate. What is the difference between the normal sealing plate and the vacuum sealing plate? On the normal sealing plate, the pressure comes underneath directly from the control panel of the SVM20-200. But here, this borehole is closed downward, and we will get the overpressure from our vacuum test unit, or even so the vacuum from the vacuum test unit from the side. So I can connect easily with a quick coupling a plastic hose and connect this one as well to our vacuum tester. Included in the scope of supply are two sealing plates. One sealing plate starting at 1 inch, going up to 8 inch or DIN 200, and the other sealing plate going from 10 inch up to 16-inch or DIN 400. Bigger sealing plates are also available upon request. To operate the vacuum tester, we need to connect it to a power supply and switch the main power on. As already mentioned, we don't need a very high force to clamp the valve onto the sealing plate. So we just clamp it very smoothly and this will be sufficient. On the Metrus vacuum tester, we are using a valve head with 3 needle valves. One needle valve for the low pressure compressor up to 0.5 bar, positive. A second needle valve for the vacuum test to down to the maximum of minus 0.8 bar. And the third needle valve to release the vacuum or even also the overpressure. With the help of a built-in small compressor, we can select now in between overpressure and due to a built-in vacuum pump, we can also select to the vacuum. The center position is switched off. So if I go now to overpressure, switch it on, the compressor will work, and now I can adjust the overpressure with my needle valve until the valve will open. Now I switch over to the vacuum test, open the needle valve for creating the vacuum, and there I can also hear a popping noise and as well see a little bit the movement on the seat area. But now, of course, we would like to know at which pressures do we open for vacuum or even for overpressure. On the built-in gauge, it would be very difficult to see or to identify an exact measurement due to a measuring range, which is going from minus 1 bar up to plus 0.6 bar. But the test result we want to see is in the range of millibars. In this reason, we have installed also in our vacuum tester a gauge quick connector, which allows you now to connect gauges with a much finer range, or even so a pressure sensor, which can be used also in combination with our FreeCRS test bench software. So here we are going to use the Vica CPT 2500 sensor with a measuring range of -1 up to plus 1.5 bar. So this one is going to show you on the computer display the measuring range from minus 1000 millibar to plus 1500 millibar. And this with an accuracy of 0.2%. So now we are going to install the Vica sensor. We can connect the USB sensor via the cable to the computer. And we see how the display changes now from positive pressure of 0 to 60 bar, now to millibar from minus 1000 to plus 1500 millibar. If you hit the spacebar on the computer, the measurement starts. I switch on the vacuum pump, open smoothly the vacuum needle valve until we have achieved the opening pressure. Close the needle valve, switch the pump off, release the vacuum until we get back to 0. Now I switch on the compressor and increase the pressure into the positive area until we have achieved the opening pressure. Close the needle valve, shut off the compressor and release the pressure. Now I hit once again the space bar and the software will show me automatically the highest pressure we have achieved. So if I would like now to generate a test report, I can push onto the BDF button, name it however I want, save it onto my computer. And now in the report is shown the highest point here with the cursor and the according test result of 21.3 millibar. Of course, I can generate also a test report with the minus result, with the vacuum result. So I just place the cursor on the minimum point, push once again onto the PDF button, and now I can save the second test report, showing me in the graph the lowest point and also the according test result of minus 10.5 millibar. I hope this video was interesting for you. Please understand, this is not a training video. We only want to demonstrate you what we are able to provide as equipment for testing breather valves. Please respect at any time the safety regulation in your surrounding. Please stay safe. Over and out.
Excellent.